Hello friends, this is Durga again from IT Varsity, a one-stop shop to learn all the technologies. So at this time we are talking about um, uh, big data certifications workshop. So most of the topics relevant to certification are covered. Going forward, I will give overview about a few of the technologies such as Oozie, HBase, etc. And then I will I will get into the performance tuning. As you guys are aware, this is the backup for the ongoing live training. So I might not be able to take your questions directly, but if you want to practice, you can subscribe to my lab by going to labs.itversity.com, and these are the plans, and you can start practicing whatever I'm covering here. And in that process, if you have any questions, you can start writing the questions under discuss.itversity.com. There are army of people who are actually following up and answering the questions. That being said, let me set up the WebEx and we'll take it from there. Hello friends. Let me get started. So if you go back to the playlist and see what we have covered so far. We started with setting up the development environment. And then in parallel, we conducted a Scala and Spark workshop and also big data certifications workshop. As part of Scala and Spark workshop, we have covered programming using Scala. We have covered Spark in detail, including data frames and all. And in parallel, we have covered HDFS commands, Scoop, Hive, and then after approximately 30 sessions, I clubbed both the 1 hour sessions into 2 hour sessions and conducted Spark streaming, Flume, and Kafka. And we have seen how we can actually get the streaming data from weblogs into Spark streaming and perform analytics on top of it. And I have given exercise on that. I hope you guys have done the exercise. If you have any challenges while doing that exercise, let me know. I will give few minutes here. I will take as many questions as you have. If there are no questions, we'll proceed with Oozie. Okay, so let me show the exercise. You have to choose big data here, and then workshop exercises. And this is the one which will give which will cover end-to-end aspects of Flume, Kafka, and Spark. Okay, so you have to use multiplex Flume agent. One thread should store the data in HDFS, and the other thread should go through Kafka to Spark streaming, and you should run analytics on top of it. Okay, so if any of you tried this and if you have any questions, let me know. Otherwise, if you want to spend these 2 hours trying it, and then if you want me to go further into the other topics, even then let me know. Otherwise, if I don't hear anything from you in next couple of minutes, I will proceed with Oozie. So when it comes to file formats in Spark, there is one video which I have recorded recently. Let me share that because we are already behind and I don't want to get into that. Rather, I will be covering performance tuning and other important stuff. But that being said, there is a video which covers all the 3 file formats in detail. And let me show you that. Okay, this is the video which you should watch. I have demonstrated using a sequence file and new API Hadoop file. I use sequence file itself as an example even for new API Hadoop file, but I have covered what all different file formats we have and how to use those things to store. There is nothing for JSON. So JSON and all, so there are few APIs in latest version of Spark where you can read data directly from JSON, but that is not relevant for the certification because certification is conducted on 1.6.2. Even then, if you are interested to understand how to read JSON and all, I think I have some samples in the GitHub. Let me check. If I have, I will share the details with you. Yeah, so there is yeah, so you can use SQL context and read data from JSON file, and then you can register temp table using that. This is one of the example which you can use, but I don't think a certification will cover this. So if you go to the certification, CCS, understanding the context is very important. Okay, if you go to the CCS Spark and Hadoop developer and check where they are talking about file formats. Sorry. So here they are talking about load RDD data from HDFS for use in Spark applications and write the results from an RDD back into HDFS using Spark. This is nothing to do with SQL context. When it comes to SQL, they are primarily asking you to query from the Hive Metastore tables using SQL context. In each of them, whatever I have done as part of that exercise to load the JSON and use data frames and register as temp table and read query the data from the temp table will not come under each of them. Okay, so here they're only talking about loading data from HDFS and writing back to HDFS in different file formats. For that, you just need to understand sc.text file, sc.sequence file, and then sc.new API Hadoop file. The counterparts to save is save as text file, save as sequence file, and save as new API Hadoop file. And for all those things, this video is a reference. You can go to that video and you can understand how data can be written or read using text file, sequence file, and Hadoop file. On top of these things, there is another API called sc.object file. Okay, but object file is only supported in Scala. It is not supported in Python. So most likely they will not touch that. If you want, you can explore. It should be straightforward once you see how I am using sc.text file and sc.sequence file as well as sc.new API Hadoop file. Object file is as simple as text file. So you can go to that video and you can go to the APIs by typing sc dot and tab and see if something is missing. I will try to cover. That. Otherwise, this is good enough. This video is good enough as per my understanding as of today. Okay. And even if you go to HDP CD Spark, I hope I answered your question, Ravati. If you have any follow-up, let me know. So even here they're saying create an RDD and create an RDD from a file or directory in HDFS. That's the only reference for the file system. And here you should know sc.text file, sc.sequence file, as well as new API Hadoop file. Okay, and then if you go to Spark SQL, here they are saying create Spark data frames from an existing RDD. So they will give you an RDD, or you have to create an RDD and you have to create a data frame out of it. Okay, if you, I don't think they will give JSON in this also, but if you want, you can prepare. if you want to give HDPCD Spark certification. And you can go to my GitHub account to the script, and you can see how you can use SQL context to read JSON file. And JSON will have metadata as well as part of the data. So we can actually register temp table using that metadata itself. And then you can run Spark SQL in SQL context to read data from this table and do whatever you want. Okay, just go through that video, and if you have any questions, let me know. Coming back to Kafka, Flume, and Spark streaming, I think no one have questions, and I didn't see much activity. If you see, there is only one click on these links, which means that most of you did not click on this gist account. Probably might have copied from, or you might have typed using the video, whatever it is. I will highly recommend to do this exercise, because streaming is one of the very important thing, streaming analytics, and it is quite hot in Bay Area as of today. Ravindra is from Bay Area, he can confirm. Eventually it will catch up in India also, and there is a lot of potential with respect to Spark streaming. The combination of streaming analytics as a concept, it has a lot of potential. It is applicable to IoT and many other broader use cases. So having the knowledge of streaming analytics can add a lot of value over a period of time. So make sure you understand these technologies, especially Kafka and Spark streaming, or Storm or Flink to perform the analytics as the data streamed in. But Kafka in itself is a very good technology to learn. So you just keep on exploring it further, and see how you can actually create consumer or producer or stream, or there's one more, persist. One of the APIs, you should know how to create your own custom consumer or publisher to Kafka topics. Okay, I will not be covering all those things, but you should focus on Kafka quite a bit. It has very good potential. And for streaming purpose, one of the technologies, Spark streaming or Storm or Flink, is good enough to begin with. Once you work on one technology, you will be able to explore the other technologies very fast. But as we are talking about Scala and Spark, I highly recommend Spark streaming for now over Storm or Flink. That being said, let us move on. Now I will be getting into other services which are there on the cluster. We have covered Hive, we have covered Scoop, we have covered Spark, we have covered HDFS, Yarn, MapReduce at a very high level. And now I will start with Oozie. Oozie is a workflow tool, and it is good to have technology, and it's very simple. It's just a bunch of commands you need to learn, and also creating the XML files and integrating the data as well as your code as part of the workflow. That's the only thing which you need to learn. Okay, so let us start with Oozie, and we will go to the architecture of Oozie. And if you see, Oozie have a server, and this server is nothing but a web service which will maintain the Oozie workflows. What is a workflow and all, we will see later. But when it comes to processing the data, or if it has to store the data, first of all, you need to understand what is relevant for Oozie. Oozie does not touch your data. Oozie is primarily a wrapper on top of bunch of applications, which can be using all those applications. We can create a workflow, and we can schedule using Oozie. So Oozie is primarily a workflow tool and a scheduler tool. It does not touch the data directly. Instead, it will invoke the programs which will touch the data. and the data could be in the file system, it could be in HDFS, it could be anywhere. Okay, and the term which used to the there's a term called action, and it is used to uh, represent the component which will invoke your underlying program. If it is Hive, it is called as Hive action. If it is Scoop, it is called as Scoop action. If it is MapReduce, it is called as MapReduce action. If it is Java, it is called as Java action. So Oozie workflow have so many actions which we can use, and we can create workflows. We'll get into details of workflows a little bit later. For now, just understand workflow is nothing but executing a series of applications in a controlled manner. Okay, and there has to be a server which needs to be submitting, which should be able to submit these jobs and also check the status of those jobs. And Oozie server is the component which will do that. So you need to have a Oozie server on one of the master nodes or edge nodes, and using that Oozie server, we'll be submitting the jobs. And jobs can be submitted from any node which have connectivity to this Oozie server. So there can be a gateway node which is integrated with Oozie server, and we can actually submit the jobs from the gateway node. In our setup, Oozie server is running on nm01.itversity.com, and we will be submitting Oozie jobs from our gateway node. In actual production implementations, we will not have servers of Oozie, Hive, etc. on name node servers. They will be isolated. There will be separate server. It is called as utility node, and that utility node will have Hive server, Oozie server, etc. And our gateway node will communicate through the utility servers to submit the to facilitate whatever these technologies are supposed to do. Apart from that, if you look at the summary of Oozie components, there is only Oozie client. Client is nothing but bunch of jar files deployed and nothing else. So typically Oozie runs on big data clusters in MapReduce to execute these workflows. So the execution engine for your Oozie workflows is nothing but MapReduce, and we have MapReduce plugged into Yarn. So it internally uses Yarn concept to execute the workflow. We will see that. We will see all those details a little bit later. That being said, let me go to, I think I have a presentation. Just give me a moment, okay? I don't know what happened. Quit. Okay. So here it is. So this is a typical Oozie workflow. So the workflow is nothing but series of programs which needs to be executed in tandem. So here we have a MapReduce program, a MapReduce streaming program, pig script, MapReduce pipes, Java program, file system. Okay, and if we have to execute all these things in the form of workflow, we need to integrate those things, and that integration is called as Oozie workflow. And if you see, the workflow has the serial flow as well as parallel. In this case, start to fork to join to decision to Java file system to end. This is nothing but sequence flow. On top of that, between fork and join, these two has to be run in parallel. So this is called as parallel flow. So you can configure either a sequence flow or a parallel flow, or you can combine both. Okay, and then there will be bunch of MapReduce programs which will control the execution of your moving parts of your application. Okay, so now let us see from the real world scenario perspective where this comes into picture. Okay, I'm opening another slide. And if you go back to the introduction, we have seen how it 1 minute, how the big data based data warehouse or analytics cluster will look like. Okay, it looks like this. We have the source systems. We have bunch of Hadoop clusters. I'm sorry, we have a Hadoop cluster where there are bunch of nodes, and then we need to get data from source systems into this Hadoop cluster, process the data in the Hadoop cluster, and port the data back into reporting database, and then your reporting tools will actually start reading data from here. If you think about it, let's say there is a report requirement. The report requirement is to get the monthly aggregated data at each store level into a fact table and generate reports out of it. Okay, so if you think about major retail stores where they have multiple databases to support their core applications, we have to get data from all the databases, process the data, and store into the reporting database. And as part of that, there could be some metadata which needs to be integrated from third-party applications. So one thread is to get the data from OLTP. In some companies, point of sale system is still mainframe driven. We might have to get some data from the mainframes on regular basis, and also we might have to get some confidential or critical data from some third-party applications. So if you think about it, to generate the aggregated data to store into the fact table at each store and at each month level, we need to get data from all the source databases from all the mainframe systems to add the revenue for each day, and for additional metadata we have to get the data from external application. Until we get the data, we should not run the follow-up process. So we need to wait until we get data from all the sources before we join data from these different sources and then aggregate it. So this entire flow can be visualized as a workflow. So invoke a scoop script which can get data from OLTP databases. Invoke a program which is integrated with mainframes technology to get the relevant data for the defined time frame, and invoke or cube the data from external applications into the file system. Once we get data from all these things, we have to process the data and then store the data into the aggregated table, and we have to run a scoop command again to copy data from Hadoop cluster into the reporting database. And from there, if there is a program which will actually blast email about the report to the executive management, we have to invoke that. And all these things uses different technologies, so we have to implement individual modules, and we have to either execute in parallel or in sequence workflow or in the hybrid manner, whatever way it is. So that boils down to something like this. So once the program is started, we might have to fork to get data from different sources and then join them. And once the data is joined from the different sources, we might want to run a Hive program, which will aggregate the data and store the data into another Hive table again. And from there, we have to invoke the scoop script to port the data into reporting database. And from there, we might have to invoke another application, which will send an email to all the relevant users who are supposed to get that report in the form of email. So we have to understand all the different actions which can be used to accomplish these things under the radar of Oozie, and this is called as Oozie workflow. Okay, so before getting into little bit complicated Oozie workflows, first we need to understand how to run simple Oozie workflows. So what I will recommend is, once you log into the lab, I hope everyone is clear what is the workflow. Okay, and we have to develop quite complex workflows, and these days Oozie is not very extensively used. Rather than Oozie, there are a couple of tools such as Azkaban. I will type in the chat. Azkaban and Airflow. Okay, do you guys know who actually started Kafka? Who is the founder of Kafka? In which company Kafka is started or made it very popular? Any guess? Yeah, Himanshu is correct. It's LinkedIn. So Azkaban is also LinkedIn's product, and it's primarily workflow tool. And people started using LinkedIn than Oozie. Oozie is very heavy. I will explain why. Oozie is less used. At the higher level, you should know all the alternatives for these workflow and scheduling tools, and you should use whatever best suits to your company rather than the technology pushed by vendors like Cloudera or Hortonworks. Even if you think about, if you're from data warehousing background, you might have heard about scheduling tools. All these workflows and these technologies are quite popular even in Java-based applications, traditional data warehouses, etc. In Java, you might have heard about something called quads. Tavantians know a lot about it. They have contributed quite a bit to that. It's an open source Java-based scheduling tool. Quads, QUARTZ. And also, when it comes to data warehousing, to perform whatever I have explained, there are tools like Control M. There is one thing which starts with Auto. I forgot. All these are scheduling tools. So first of all, you have to separate the workflow and scheduling, and there could be one tool which do workflows very well, and other tool might schedule well. But most of these tools have capabilities of both workflow as well as scheduling. But if you want, you can separate them out also. Okay, so when it comes to Oozie, people only use Oozie workflows, and that too, people are moving away from Oozie and start embracing technologies like LinkedIn, LinkedIn's Azkaban or Airbnb's Airflow. They are much more simple to implement and less overhead on the cluster compared to Oozie. Okay. Anyway, I will explain the drawback and why the overhead is very high with respect to Oozie once we see a few details about Oozie. So I'm logging into the lab. I'm creating Oozie demo directly here, and I'm going here. And as part of Oozie itself, there is a tar file called Oozie examples. So you can just copy the Oozie examples tar file, gunzip, and see all the sample actions or work yeah, samples for each and every type of action such as hive, MapReduce, Java, etc. Okay, and the location of that is slash user slash HDP on our cluster. This is the location HDP 2.5.0.01245 Oozie lib, and you can say Oozie examples and hit enter. Oh, not there. Yeah, so it's under Oozie doc. Okay, this comes as part of the open source Oozie itself, and it is integrated with Ambari. Even with Cloudera, you will find this in the appropriate location where the binaries are deployed. Okay, so let us copy this, or you can also, yeah, let us copy this. I will just copy and then run tar xzf. So this is a tar compressed tar. X is to extract the tar, Z is to uncompress, and you will see a directory called examples here. And if you go to examples, ls-ltr, you see three directories: source, apps, and input data. Okay, source is, I think, for source code. We don't need to worry too much about that. Just go to apps, and you see there are these many actions. There is a scoop action, there is a spark action, there is a pig, hive, uh, Java, there is Java main, MapReduce, SSH. There are all kinds of actions. Okay, so let's take the example of Java main and see what are there in that. So there is a workflow.xml file, there is a job.properties file, and a lib directory. So lib directory is the one which will have the compiled jar file from which we want to invoke the application. So this jar file have, I think, hello world program or something, and we'll be invoking that. And that is actually driven by workflow.xml. So if you look into workflow.xml, just give me a moment, okay? So it starts like this. You have workflow app. I'm sorry for the noise. We have the workflow app, and then it's a very small one. It is not a, yeah. And then the first tag under this workflow is start. Okay. And here we are giving a start, and we are saying to, which means that we are telling where to go once we start. Okay, there is only one action here. If there are multiple actions, you can say any action name, and if you see this one and this one matches. So if you say start to equal to one name, and if there is an action with that name, it will go to that. And in that action, we will tell, this main tag will tell what type of action we are trying to use, whether it is Java or Hive or Pig or Spark. We will give all those, we will use appropriate action here. This will actually control what type of action we are trying to use. All these are just names, even though there is a reference to Java and all, they are just names. You can give any name to it. Okay, and then this is nothing but a simple Java program which I want to run on the Hadoop cluster. Okay, to run it on Hadoop cluster, we need HDFS details, which is nothing but name node, and we need yarn details, which is nothing but job tracker in this case. This tag is a little bit misleading, whether you are using older version of Hadoop or newer version of Hadoop. We use job tracker itself to tell the master of our processing engine. In our case, resource manager IP address will be passed using job tracker. And here we are using environment variable notation or variable notation rather than hard coding the value. And the values for these parameters will be part of job.properties, which I will show in a moment. Okay. So here we are telling which job, which queue this job should run, and what is the main class needs to be invoked, and what are the arguments you want to pass for that program. So I'm trying to pass two arguments using arg tag, and then once Java tag is done, we are saying OK to equal to end and other to fail, which means that once this program is executed, if it is successful, it will go to end to the tag which have the name at the end. Otherwise, it will go to the tag which have name as fail. Okay, and if you check the tag with name end, the type of the tag is the end, and we are not taking any action. We are just successfully closing the and the workflow. So in the end, it will come to this if it is successful. If it is failure, on the so on error we are saying it as fail. So then the tag type for fail is kill. We are just killing the job, and we are actually printing the message saying that the job is failed. Okay, so the takeaways from this is we should have a start tag, we should have an action tag which will control the type of the tag, and the parameters as part of subtags as part of this main tag will vary depending upon what you are using here. And then for all the actions, we will have once the action is completed, we have to define what needs to be done if it is successful and what needs to be done if it is failure. And then there should be tags with those names which takes appropriate action in case of success or failure. Okay, this is the sample workflow example. And then I don't recommend you to type, just copy these examples and start exploring from there. It will save a lot of your time. If you start typing, you might make silly mistakes which might be very tough to troubleshoot. Okay, now you see, so earlier if you see the workflow.xml, and now job.properties. In the workflow.xml, we are using a variable job tracker, a variable name node, a variable queue name, etc. Okay, and here we are actually providing values for those. So job.properties is nothing but a configuration file for our workflow. So name node is this one. If you see, it is pointing to localhost, so we have to modify this to match our cluster. Otherwise, it will try to run locally on this node itself, which is GW01. Okay, so we'll make the necessary changes in a moment. And then job tracker also, we need to give the IP address and port number, queue name, whatever you want, you can give wherever you want to run. Leave it as default. Examples root is primarily to replace this one. And once these values are replaced as part of the properties, this will change to this Oozie WS application path will change to something like this. Okay. Whatever is in name node, that will be replaced at the runtime. And then user, and then $user.name, it will pick up the OS user who is trying to execute this job. In this case, it is BGADI RAJU. And then examples root. This example root is also an variable or parameter. In this case, examples. Okay, so this will resolve into this, and you need to deploy this application matching this path. Okay, once you make necessary changes or you develop workflow.xml, job.properties, and have the compiled code in lib, you need to deploy that entire directory which will match to this. If they are out of sync, um, then you will not be able to execute the workflow. Okay. So that being said, before making the necessary changes and deploying it on the cluster, let me do few more things here, and then I will show you about how to deploy. So first we need to validate. We can connect to the Oozie server and check the status and few other things, version, etc. before submitting the job. If you cannot connect to Oozie server, there is no way you can submit the job. So first, let us understand how to validate. Once you start working on a new service which is deployed on the cluster, first thing you should do is preliminary validations whether you can connect to it or not. For that, there is a command called. So I'm going to Oozie user guide here. Okay. So you can say Oozie quick start. And don't try to set up because we already have as part of the cluster. If you want to do it locally, you can do it. Okay. And the important command here to validate is this one, Oozie admin. So Oozie admin -- Oozie http colon. We have to figure out where our Oozie server is running. For that, we have to go to Ambari, and it is running under nn01.itversity.com. And also we need to check the port number. Okay, default is 11,000, but before we start using it, let us check. See here. So this is the base URI which you can use. You can just copy paste that one here and then status. What is the command? Hyphen status. So it is normal, which means that you are able to connect to the Oozie server, and we can actually start submitting the jobs. There are a few other commands also. I think you can get the version of your Oozie server by saying version here. It is 4.0, 4.2.0. This is the main Oozie version, and this portion is about Hortonworks distribution. Okay, so you should focus on this only. Okay, and then we have to make the necessary changes. So we have confirmed that we are able to connect to the Oozie by running the status command. Okay, so now I will try to push this Java main into my location in HDSS. So I have Hadoop FS ls/user. I will try to create a directory here which says Oozie example or Oozie demo, and I will deploy all my Oozie applications from here. So I have to copy this Java main directory to that location after changes are done. So I will take care of it. First, I am going to Java main, and what is the location I want to deploy in HDFS? User D Gadiraju Oozie _ demo. Okay. So first thing you need to worry is in the job.properties, your Oozie wf.application path should match where you are deploying. So in this case, I'm not going to deploy under /user /dgadraju examples apps Java main. Instead, I want to just deploy here Oozie example. Okay, and then Java main. Or I can do one thing. I can actually say $examples root Java main. Okay, and here I'm deleting this one and replacing with Oozie underscore example. Okay, and now we have to give the HDFS name node and resource manager IP address and port number. So when it comes to HDFS, you go to Ambari, or from the command line also you go to coresite.xml. Where coresite.xml will be? Can you guys recollect where we can get coresite.xml? From command line. It is very important to remember that location, and it's industry standard. You should not forget that. Where our core site, HDFS site, yarn site, MapReduce site.xml files will be on the command line. I'll give 10 seconds for you, or probably 20 seconds for you to think and get me the answer. You can even Google. At least guess. Okay, so you guys forgot. So it is very important to remember this location. On Linux, almost all the properties files will be hidden somewhere under /etc. Okay, /etc is the special directory to store all the configuration files. Take any example, SSH or any other core Linux module. All these things, most of the default location for their configuration files will be somewhere under /etc. When it comes to our big data tools we have on the cluster, for each of these tool as technology, there will be a subdirectory in this. For HDFS and MapReduce, there is a subdirectory called Hadoop. For Hive, there is a subdirectory called Hive. For Scoop, there will be a subdirectory called Scoop. For Spark, there will be a subdirectory called Spark. So for each and every technology, there will be a subdirectory here, and it's a standard location. Okay, so in this case, we are talking about coresite HDFS. So HDFS related XML files will be under /etc/Hadoop, and there will be a subdirectory called conf. Okay, you just have to replace this one for different big data technology. For Hive, it is /etc Hive conf. For Spark, it is /etc/Spark/conf. Okay, and then if you do ls-ltr, you will get all the XML files, shell scripts to set the environment variables, log4j properties files. Everything will be under this location. And if I go back and the details of what we have under etc Hadoop, this conf is nothing but a soft link for the repository which is internally managed by Hortonworks. In a typical or plain vanilla Hadoop, you might not have these soft links, but with respect to Hortonworks and Cloudera, irrespective of where they actually store the configuration files, to match with the industry standard, they provide soft links under /etc/Hadoop. So most of the distributions, unless some hardcore administrator want to completely confuse the people, everyone will have the configuration files under /etc/Hadoop/conf. Okay, and here you can go to coresite.xml to get your name node IP address and port number. We just have to copy this one, and also you can go to Ambari here we are talking about HDFS. We want to get some configuration information. You can go to configs, and then you can search for the ss.default ss, and we will get the IP address and port number here also. Okay. So is it clear now? And you should not forget this. You should be able to answer this at any point in time. Even in the midnight, if someone wake you up and ask about this, you should be able to tell. It's that important. Anyway, let's go to Oozie demo and then examples and then apps, Java main. And then vi job.properties. So here I just have to paste the name node URL, and for job tracker you can go to yarn, because for processing yarn is the framework, and there are a bunch of parameters which will have resource manager in them. You have to search for those resource manager based parameters, and you will get the host name here. And also we are interested in the port number also. So here I need to confirm 1 minute. Yeah, so this is the one, yarn.resourcemanager.address. This is the IP address and port number which you need to give. Okay. Okay. And also, earlier to troubleshoot the jobs, we used to get something called resource manager UI, and for that resource manager UI, port number is 8088. And that is to view the details about the jobs that are being executed or are already executed. Whereas this one is the main port number on which the resource manager itself will be running. Similarly, is the case with the name node. 8020 is the port number on which name node will be running all the time, and 50070 is the port number on which you can get the view of the files that are stored in the Hadoop cluster. Anyway, just go to the way you should fill the details about name node and job tracker is you should check for fs.default fs in coresite.xml, and then yarn.resource manager.address in yarn site.xml for job tracker for name node. Okay, so you have to change to these things to run in as an example. Okay, now once we are done with this, now this path will be represented as nn01.itversity.com, and then examples root is changed to Oozie underscore example. Okay, so we have to have our Java main folder in this path in HDFS. Only then we will be able to run. So the integration between the job.properties and the execution is primarily through oozie.wf.application path. People tend to make mistakes here and they will be confused. Once that is done, go up to the directory in which we have all these lib directory, job.properties and workflow.xml. and then run Hadoop ss hyphen put Java main. This is the directory I want to copy into user Raju Oozie underscore example and hit enter. Now we have our application deployed in HDFS, and now we have to start. To start, again, you can go to the Oozie official documentation. And go to running the examples. So here they are saying copy the directory using which you want to run, and then you can actually use this command. Okay, I'm copying to Sublime Text. Here I have to say NN0, sorry, Oozie server. Okay, so Oozie server is running on 11,000. So here we have to give port number as 11,000, and it is running on nn01.itversity.com. And then this config, we have to tell where our job.properties is locally. This is not the HDFS location. Here we have to give the local path. And the local path is /home/dgajraju. I think I have to run pwd here. And copy this one. /java-main. Okay. This is the, we are only giving the path. We are not telling what to be executed. Yeah, we have to give the path of the job.properties. Job.properties. And then -run will actually run the command. So we can actually start now. So here I have given the fully qualified path of job.properties. Hence, I can run this command from anywhere. I don't need to be in this directory. I can be anywhere on this machine. As long as I have access to that directory, I'll be able to run the job. Okay, so here something is wrong in HDFS location. So first we have to troubleshoot this one. Hadoop ss-ls. Okay, my put command is not correct. So let me delete these files and then run the put command again. Now let me make sure that the Java main is there under Oozie underscore example. Yes, now the Java main directory is there. Now let me run the command. Now you see it has given the Oozie ID. This is Oozie ID. This is not MapReduce ID. And we can actually say -info here along with that job. Okay, and it will actually show whether it is running or not. It is not running right now. It actually started, invoked the Java node, succeeded, and eventually it is completed successfully. And this is the MapReduce job on which this Java program is executed. You can actually go to Resource Manager, web interface, and we can actually go to the history and then go to the job details. There's only one task. So we can click on map tasks and click on this one and go to logs. And here, this is the functionality of the program. There is nothing much. We are passing hello and Oozie as the parameters, and it is just displaying the each of the arguments which is passed to that program. A simple Java program. It's not a MapReduce program. It's simple Java program which is run by the MapReduce, and this is the output of it. Okay. So this is how you can run the job, and then you can validate. So I will give 10 minutes to you. I'll probably, it's 11:35 now. I will give 15 minutes time. So copy the jar file. The location of the jar file I will give. So this is the location of your jar file. And then you can run, you can copy to any location you want. And then you can run tar_xdf on that file, which will create examples directory. Okay, and go to that example directory. You will have apps in that, and then you will have Java main in that, and try to make the changes to the Java main to point to the name node and job tracker, and try to run this program. And if you run into any issues, I will let you know. And once you test this in 15-20 minutes, I will go to the further topics about how to write Hive action, and then how to perform. I will get into few important details like forking and all those things, and probably I will give an exercise where you can create an end-to-end flow. We will try to wrap up today, Oozie, from the theory perspective, and I will give an exercise to you, and I will leave it for you for writing a little bit of complex workflow. But I will try to show an example for each of those things. So right now it's 11:35. I will give 15 minutes time. You can go ahead and start doing the exercise. And if you have any questions, you can ask me. So I think Himanshu or someone have asked a question. Priyanshu. I don't know what Oozie demo will come. I do not understand the statement, Priyanshu. But if you have any question, you can ask. I will explain. So anyone tried so far? If you think I did not give enough time, let me know. I will extend it a little bit further, but it should not take more than 15-20 minutes. I'll grab a glass of water. So I'm back. So 3 more minutes. Anyone successfully did the ran the Oozie program? And let me paste you these commands to run. So this is the command to run, and to get, once you start, it will actually give the Oozie ID for the job. Then you have to give the Oozie job ID and then -info to get the details about the job that is being running. So we have 2 more minutes. Let me know if you need more time. Otherwise, we'll start in a minute. Okay, so let us start. So we have seen how to run a simple Java program. It is nothing to do with MapReduce. Now we'll get into a little bit more complex examples. So the next example which I'll be showing is Hive. Okay, so you have there are two actions for Hive and Hive for Hive. One is Hive and other one is Hive2, and also we can use hcatalog, I guess. So for this example, I will be using Hive2. So let us see what is there in that. And as you have seen earlier with Java main, here also there is workflow.xml, workflow.xml.security, means if you want to configure against Kerberos. And then there is a script, script.q, and then there is job.properties and workflow.xml. They also provide README. Okay, they also provide README. You can have a look at that to understand what all the instructions they have given as part of it. So most probably they might have. Okay, so there is only one statement for secure clusters. Copy workflow.xml.security to workflow.xml and fix the metastore location appropriately. For non-secure version, we can just remove that xml.security. It is not required. And then we'll start with the job.properties. As part of the job.properties, the name node, I have to change it to mn01.itversity.com, and job tracker rn01.itversity.com 8050. And queue name examples, everything I will leave like this. This additional setting is required so that it can access all the libraries to run the Hive query. Okay, I will leave as is except for examples root. I will change it to Oozie underscore example. Rest of the stuff I will remain. I will keep them same. I will copy the entire apps directory, which include Hive, into this location so that we can use the Hive. We can invoke Hive. Or I will create the apps first, and then I will copy Hive only into HDFS before we deploy the job. Okay. Now come out of this and go to workflow.xml and see what we have. So I hope you understand what is start, what is okay, and kill and end here. On okay, it will go to end. On kill, it will go to fail. Sorry, on error, it will go to kill. On start, it is going to Hive node. Hive node action have Hive as subtag, and it have the details such as job tracker, name node, etc. And for most of these actions, there is something called prepare. What this prepare will do, so in case of MapReduce job, right, if the directory already exists, when you try to write, it will complain that directory already exists. So if you want to take care of some pre-processing activity, you can use a tag called prepare, and in this case, we are deleting the directory, and then we are creating this main directory to store the data. So if you see now, under the examples root, if you go back here, so this is the examples root up to examples. We have only source, apps, and input data. And now if you go to the Hive workflow.xml, as part of the prepare, it is trying to delete the output directory along with subdirectory Hive2 in that, and then it is trying to create this output data. So first time, if the directory structure does not exist, it will just create this one. And as part of the job, this additional subdirectory will be created. But if you run subsequent times, it is just invoking this pre-execution script to delete the directories and recreate the directories for our job to run. Okay, and then as part of the configuration, you can overwrite any parameters. As of now, we are only overwriting job queue name. But if you want to change the number of reducers and all those things, you can overwrite those parameters. And then you have to give the JDBC URL here so that Hive2 actually uses JDBC to connect and execute the script. Using JDBC URL, it can connect to the Hive server. And this JDBC URL, again, we have to go to job.properties. Okay, earlier I have changed it under Hive. I should have changed the Hive too. Hive, there was an issue related to permissions, and you will not be able to run Hive action. So if you want to execute Hive script, try to use Hive to example than Hive. So now I am actually changing the Hive to job.properties. Earlier I changed the incorrect one. Here it has to be IT Varsity. Yeah, rm01.itworksity.com 8050. Queue name is default, and here we have to get the Hive server tool. How we can get that? Either you can go to etc hive conf hivesite.xml file, or you go to Ambari. Okay, click on Hive, and then search for Hive server. And this is the port number. IP address is somewhere it should give the IP address also. Anyway, we can figure it out by going to summary and Hive server 2. So this is the one on which it is running Hive server 2 and port number is 10,000. So here I just have to say like this, and then I have to give the database name. In my case, I want to run against the database called dgajraj. And then examples is the root and rest of the stuff is same. Okay. Examples root I will change to Oozie underscore example. Okay. So now we have made the changes to job.properties, and then we will also look at the script what we have. We are trying to invoke this script. What it is doing, it is actually creating a table called test, and then it is actually creating an external table pointing to input path, and then loading into the directory by querying from this table. Okay, so all this input, output, etc. will be replaced by few settings in workflow.xml. Now, if you go back to the workflow.xml, we are invoking the script.q, and we have input path. So this will be the input path, input data table, and this will be the output path to which data will be copied to. Okay, so first let us understand what we have in that input data, and then it will create the table. We will validate the output path, everything. Before doing all those things, let me copy this Hadoop SS. I am first creating the directory user Raju Oozie underscore example slash apps. Okay, and then I am copying apps Hive2 to this location. Okay. And also there is one more thing which I need to copy. Put apps input, sorry, input data to this location. Okay, now if I do Hadoop fs-ls and paste here. So this is the files which is in HDFS. We have input data, we have apps directory, and in the apps directory, we have only Hive2. We don't have anything else. And that Hive2 have all the job.properties, workflow.xml, and script.q. Okay, and we have already made the changes, and when we run the job, it will make necessary changes. And if you look into the script once again, I'm going to apps hive2 workflow.xml. If you see, our input data is from this location. So if you go back and under Oozie example, if you search, I have copied input data also into HDFS. So input data and hit enter. There is a, I think, input hyphen data. Okay, there is a directory called table. So this is the input data for our Hive script. Now if I do that on this workflow.xml, the output will be eventually be in this location. So if you look into the script.q, first it is creating the external table pointing to our input path, which is nothing but that input data table directory. And then it is querying from that table called test, which is pointing to this HDFS location. And then it is inserting into the output directory. What is the output directory? This is the location. So once the job is done, you need to have this output data directory with subdirectory hive2, and it should have the output of the query select star from test in that location. So that's the purpose of this script. Is a simple hypothetical example and nothing complex to see that we can invoke the Hive script using Hive action as part of Oozie workflow. Nothing complicated in this. So now I have to copy this. Sorry, it is already copied, so we don't need to copy. Now I need to run this. Okay, so to run it, okay, so so here we have to give the local path. Our local path is home, dgadraju, Oozie demo, examples, apps, and then here we have to give hive2, and then job.properties -1, and then hit enter. It has created the job. Take this job ID. And copy this location. And then run info command on it to see the status. Sorry. Oozie, let me see. Okay, so this is the command. Okay, now you see job is succeeded. So we can go to the resource manager web interface to see if the job is succeeded, and also we have to make sure what it have done as part of that job, and eventually we have to validate whether our Hive script is ran successfully or not. And this is a very important step to validate after the job is executed. So here I am going to rm01.itverse.com 8088, which is the port number. So here you can see it has actually created two jobs. One is saying it's a Oozie launcher. So this Oozie launcher is a MapReduce job which will actually invoke the action in the workflow and keep track of it. So this MapReduce is the one which will, this job is the one which will see if the job is successful or not. If the job is successful, it will go to the OK tag. If the job is failure, it will go to the kill tag, because of the configuration we have provided. And it is all taken care by this one. This will not touch the tables, directories, etc. This only will invoke the Hive script. Hive, in the previous case, we have only one MapReduce job to launch the Oozie job, but we did not see the second MapReduce job because we are trying to invoke a simple Java program. But in this case, we are invoking a Hive program, and that Hive program is nothing but it has an insert statement, and that insert statement has to run in MapReduce. That's why you see another MapReduce job just for that insert statement. Okay, so depending upon what you are trying to do, if it includes invoking a MapReduce, this will take care of it. And now you can go to the history of the first job which launched the Oozie, and go to the logs of the task to see what is happening. And here, the way you launch Hive and run the Hive query, similarly, what this Oozie launcher have done, it just connected to Hive using JDBC, because we are using JDBC in this case. Okay, using JDBC, it connected to Hive and it just ran the query as a client. So in this case, this MapReduce job, which launched the Oozie workflow, acted as a client to the Hadoop cluster to invoke Hive query. And Hive query runs in MapReduce by default in my cluster. Hence, it has created the second MapReduce job. And if you go to the logs of it by clicking on history, interesting, it shows 0 map tasks, 0 reduced tasks. But it says succeeded. Okay, I know why it did not create the MapReduce job. The reason is the query is very simple: insert, select star from. Hence, it did not created any map tasks or reduce tasks. It just created a program, a driver program, and did some things under the hood without invoking the MapReduce program. That's why we are not seeing map tasks. So even though it invoked the MapReduce program, it did not create map tasks and reduce tasks. So what it have done is, first let us validate whether we have the output data directory now. Hadoop SS ls user d gadiraju Oozie underscore example, and you see there is the output data now. And let us see what we have in that. There is a file directory called Hive2. Okay, and there is nothing here, so there is something wrong. Okay, so the way we should validate is by launching Hive. It does not throw errors also, and it is saying succeeded. Something is wrong. Use D Gadiraju, show tables. I know, I think this test is there from earlier. Describe test, select star from test. Okay, so that's the reason why this is there for some time. I think describe, formatted, and hit enter. Create time March 21st. Yeah. Okay. Now let me check this location whether it have files or not. DFS hyphen ls. It has file. Why it did not? Okay, this file is empty. Okay, let me see. I know the problem. Okay, Hadoop DFS hyphen cat. Okay, this file is empty. So let me see Hadoop. So I'm in the examples directory, input data table. I'm going into the examples which we have locally to see. Yeah, this is the problem. So this file is empty. I don't know why it is empty. Now let me do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now let me run it again. Because there is no data, it did not work as expected and it has caused a little bit of confusion. So here I'm running it again. It gave the job ID. Now it is running. And now let us go to the resource manager web interface. Yeah, now let us click on the history. Okay, even now it is saying no map tasks or reduced tasks. But let us go to Hive. Okay, I know why. I have to drop this table also. Select start from test. Describe formatted test. Okay. Sorry, what I am supposed to do is I have data in the local file system. I haven't copied into HDFS. So let me first drop this table. Okay, I dropped the table. I came out. So earlier what I have done, so I have modified this local file, input data, text, and then I have updated this data.txt by adding 1 to 10, but I haven't copied to HDFS. Because I haven't copied to HDFS, still second time also, even the job is successful, we didn't see anything. So now let me go back here and delete the directory, input data directory, rm-r from my HDFS location, Oozie example, and then input hyphen data. Okay, now let me copy it. Now we have the data in HDFS. Now I will run the job again and see if we can get the data at the output once the Hive script is executed as part of uh, Oozie workflow invoking the Hive action. Okay, so now it is running. Let us go back to here. So now first it started the Oozie launcher. It haven't invoked Hive script yet. Now it has invoked the Hive script. And let us click on application master. Now you can see the map task. Okay, and if you click on map, if you click on task and go to the logs, you will see that it has actually done something. Okay, now you can launch Hive. And then select star from test, and we have the data in the table now. And also, if you come out of Hive and then run Hadoop ss -ls user d gadiraju Oozie underscore demo, you will see the output data directory here. Sorry, Oozie underscore example. This is just created, and if you can go to output hyphen data, there's a Hive 2. So this is the directory into which we are trying to insert by querying from the table test. And you can see the file here. And you can say Hadoop ss -cat on this location. And you can see the data. So this is how you can invoke the Hive 2 workflow action. Similar to that, we have scoop, we have map reduce, we have many more. Anyway, I will, rather than going into those individual actions, now I will demonstrate you how to create the sequence flow. Now we will take a little bit of real world example, and we will try to demonstrate something. Okay. So we have, let's say, let me think about how I should demonstrate this. Okay, so first I am creating a new database in Hive, which is dgadiraju underscore Oozie. Create database dgadiraju underscore Oozie. Okay, and I also have I also have public retail underscore db in HDFS. All right, let me validate that I have data over there. Yes, I have data part -000 for orders and also order items. Okay, so let us assume that we are reading these two. We are getting data using scoop from these two tables. Okay, sorry, we have MySQL database, and in the MySQL also we have orders and order items, right? So first let us try to use Scoop to read data of order and order items in parallel. So we will be seeing how we can invoke multiple actions in parallel, get the data once the data is retrieved, how to invoke the join between the order and order items, and finally store the results in MySQL, back in MySQL database again using Scoop export. So first let us design. So I have a MySQL database which can be connected using user retail underscore DBA and host and then 01.itvarsity.com, password is itvarsity, and then use retail underscore DB, which is the database, and show tables. Okay, so we have orders and order items here. So we have to get the data from both the tables in parallel. Once we receive the data from both the tables in parallel, then we will actually perform the join on both the data sets using Hive query and store the data into a new Hive table. And from that table, I want to invoke Scoop export and store the data back to this retail underscore export database. We will create a new table in this to close it and load the data into this. Okay, so let us start. I'm coming out of this. So I am creating a new directory here under Oozie demo. I am saying daily revenue. That will be my application. Okay, so what you have to do first? First, you can copy job.properties from the Hive 2 directly, which we have tested already. So where is it? It is under /home examples apps Hive 2 job.properties to here. Okay, I will also copy workflow.xml to here. Okay, so I will start with this one as a template. Okay, so first what we have to do, we have to invoke the Scoop. So probably let me get workflow from Scoop rather than from Hive 2. So I'm copy from this location. There is a Scoop directory here, and then copy the workflow.xml to here. Okay, so in the workflow.xml, first let us test whether we will be able to retrieve the data from table called orders. Okay, so for that, we can issue command from here. Okay, so here my command will be jdbc mysql // nm01.itvarsity.com 3306 /retail underscore db. That is the database, and then table name is orders, and then my target location. We have to do the Hive import. Hive import Okay, and then Hive database. Database name is Raju underscore Oozie. And then we don't need to give all these things. So this will, first we will just run the scoop, one single scoop command to make sure that the scoop action also is working. And then we will try to create a fork to fork two scoop commands in parallel. One will be fetching orders table, other one will be fetching order items. And then we have to, once both are done, we have to join the output of both the actions using Hive action. And then we will actually do the processing in Hive and save the output back in a Hive table, and then we will do the scoop export. Okay. So first, let us run this. It might fail because of JDBC drivers. We will see. So now I would like to copy this. Okay, let me do this. We have to make few more changes. So if you go to job.properties, these are okay. Name node is correct. Job tracker is correct. Queue name is correct. And examples root is not applicable. Here I will be having daily underscore revenue as the directory. Daily underscore revenue. Okay. And then I will copy this Hadoop SS hyphen put daily revenue into slash user slash dgadaraju slash daily revenue. Okay. Once you copy, then you can actually run the command with path to properties file. Daily revenue. And then hit enter. Now the job is running. Let us see the status. It might fail. We will fix if it fails. And I will share this these examples in this tomorrow. It failed, and if you look into the reason why it has failed, for that you need to go to the MapReduce job. I think we can get the errors from here also, from command line also, but we can also get from here. So let me go to Resource Manager web interface. So those who are aspiring for certification, I have covered everything related to old CCA certification as well as new CCA certification already. I have covered Scoop, I have covered Flume, I have covered Spark with Scala, HDFS commands. So everything with respect to certifications, it's done. We are now focusing on the overview of other tools, and then we will also see performance tuning over next week. So it failed. It even failed to start the job. So I need to check the errors. I think instead of info, if I say log, I will get the details about where it is failing. It is saying examples root cannot be resolved. Okay. So here I have to go to daily revenue, workflow.xml. Okay, we don't need to run this prepare script. And now let us start. And I have to first copy this one. I can use -f to copy forcefully to overwrite the files. And now run the job. Again, it is failing, so I have to go to the logs. Okay, Hadoop access-cat user Vigadiraju daily revenue workflow.xml. I have deleted, so the put command that does not work properly. I know the problem. So you have to be extremely careful while copying this. I should have given this one. Hadoop access-rm -r. I think it has created subdirectory earlier, so I'm just cleaning it up. Yeah. Now I'm running it again. First info command to see whether the job is being running or failed or successful. Again, it gave error. What? Hadoop. I deleted this. Okay. CD daily revenue. PI workflow.xml. Hadoop. Let me get the commands right. We will. I will stop in few minutes. We are almost at the end. I will just test this one and then I will try to create fork and all by tomorrow and then I will execute tomorrow. Okay, -help. And then I am trying to see put command. Yeah. -f overrides the destination if it already exists. That's what I have done. Anyway, let me do this. -put. Okay, now let us do the cat. Yeah, now it is cleaned up. And then run. And then info 28. Okay, now it is running. At least MapReduce job is submitted, but the MapReduce job is failed. So now we cannot get the logs from Oozie. We have to, I think we will get, let me see. Log, let us check the log if it give any error information. So here it did not give any much of information about why the job is failing. So it is successful in creating the or launching the action. So that action will result into a MapReduce job in this case because we are trying to do scoop import. And while launching it, it might be failing. Okay. So from Oozie perspective, it actually created the job and it gracefully handled the exception. That's why it is saying succeeded. But that doesn't mean that the work is done. Okay, work is failed because the task itself is failed. And if you go to the logs here, you can see the exception. There is no JDBC driver. So we have to actually pass the JDBC driver to invoke this scoop import, because if you think about it, this the Oozie, the MapReduce job tool, which is created to launch the Oozie workflow, it will be running on one of the worker nodes. So in this case, if you go back and see the details about this task, it ran on wn01.itversity.com. Now if I go to wn01.itversity.com and check for MySQL jar, it might not be in the location where we are looking for. It might be somewhere else, but it might not be in the class path. That's what have happened here. Okay, you can see there are files in some of the caches, but not under /user/hdp/2.5 blah blah blah. Okay, that's why it is failing. So what we are supposed to do, first we have to invoke that scoop import with relevant MySQL connector jar file, and it will take care of creating running the job. Okay, so I will try to fix that before tomorrow's class, and also I will come up with the workflow which will have fork join and the complete workflow. I will just explain it because it will take time to type, and then I will invoke and demonstrate end to end about a multi action workflow. That being said, if you have any questions, I will take. Otherwise, we'll wrap up for today and catch up tomorrow. Any questions here? So the reason why you need to understand few of these concepts, especially the parallel flow, serial flow, etc., is that irrespective of the workflow tool you use, the concepts will remain same. You should design your application exactly the same way I am explaining to you. The technology might be different. It could be Azkaban, it could be Airflow, it could be anything. Okay, so that's why I'm going to that extent and explaining all these details to you. Okay, then, that being said, thank you very much. We'll catch up tomorrow. Those who are on YouTube Live, thank you very much for joining the session. We'll continue on Oozie tomorrow, and we'll also start on HBase tomorrow. And day after tomorrow, I will cover Ambari in detail. And there will be no class on Friday. And next week, there will be 3 classes. And those 3 classes, I will be covering the performance tuning in detail. That being said, I hope you're enjoying the content. If you like this video, please click on the like button. Sorry, I hope. Yeah. So if you like this video, please click on the like button. If you want to share with your friends, please click on the share and share with your friends. And if you need environment to practice, just use labs.itversity.com. Whether you sign up for the labs or not by paying money, you can still ask your questions under discuss.itversity.com. That being said, thank you. Bye.